Welcome to C2.1.4, Filtration and Crystallisation. So our learning objectives for today are to recall what the key terms soluble, solute, solvent, solution, saturated mean, describe the process of crystallisation and filtration, and explain how crystallisation and filtration are used to obtain pure chemicals. So first of all, our key definitions. So we need to know the 5 S's. So soluble describes a substance that will dissolve in a given solvent. So for example, sugar will dissolve in water, so it is soluble in water. A solute is a substance that dissolves in a solvent to form a solution. So if I, in that aforementioned example, if I take if I take sugar and dissolve it in water, then the sugar would be the solute. The solution is a mixture that forms when one substance dissolves in another. So again, if I take my sugar, dissolve it in water, that forms a solution of sugar in water. So the solution is the mixture that forms when the sugar has dissolved in the water. Saturated means that, so a saturated solution means that it contains the maximum mass of solute at a given temperature. So if I took a cup of water and I added a spoon of sugar and stirred it, it would dissolve. If I added a second one, it would probably still dissolve. But at some point, if I add enough sugar and stir it, when I stir it, it won't dissolve because there's so much sugar in there that there's no more space for any more sugar to dissolve. And at that point, we call it a saturated solution. And lastly, solvent. So solvent is a substance that can dissolve a solute to form a solution. So in our previous example of sugar in water, the solvent would be the water because it dissolves the sugar. So you should have met these terms before in Key Stage 3, so this should just be revision. So here's a slide showing you an example. So here we have sugar being added to water. So the sugar is a solute, that's a solid that's being added. The solvent is the water, and if you stir that, you would then form a solution, which is your mixture of your sugar and water. So we also need to know the term insoluble. So soluble means it does dissolve in a particular solvent. If something's insoluble, it means it won't dissolve. So for example, nail varnish is insoluble in water. And here we've got some sand. So sand is insoluble in water. So if you mix sand with water, it does not dissolve and it just sinks to the bottom. So instead of being a solution because it hasn't dissolved, we would just call this a mixture. So it's a mixture of the insoluble solid and the water in this case. So we need to think about what's happening here when we dissolve because it explains saturated solutions. So this slide talks us through salt being dissolved in water. So it's a very crude, simplified diagram here. So the water particles are shown as blue circles. Of course, water particles don't actually look like that because water is H2O, so it's got 2 hydrogen atoms joined to 1 oxygen atom, so it's a molecule, but to simplify the diagram, we're just showing the molecule of water as just a simple circle. So they're the blue circles, and you can see that the salt particles are shown as yellow circles. And again, that's a simplification because salt's an ionic compound, but we don't need to worry about this for the purposes of this diagram. So when you mix salt in water, because it dissolves, you form a solution. So what happens is when you think about a liquid, so waters are liquid, and if we think back to our particle diagrams of liquids, they're randomly placed, but the particles can move past each other, and there's small gaps in between the water particles. So the salt, when it dissolves, goes in between these water particles to give the diagram on the right-hand side. So the salt particles will break apart into very small particles of the salt, which will be then in between the gaps of the water. And again, this is a simplification because it's an ionic compound. It actually splits up into ions, so it splits it up into Na plus and Cl minus, but we don't need to worry about that at this point. So in our solution, this is the case for any solution, the particles from the solute, which is the substance that dissolves, are no longer closely packed together. So instead, they're going to be spread out evenly between the particles of the solvent. And this means they're very small particles, which will become important when we talk about filtration. So when we talk about a saturated solution, so we said a saturated solution means that it's got the maximum mass of solute at a given temperature. So the amount of mass that you can add will depend on the temperature of the solvent. So if we think about our diagram of our salt in this case, with the particles spread out in between the gaps of the water particles. So because the solute is being put in between the gaps of the solvent particles, there's only so many gaps in between the solvent particles. So once those gaps are filled, there's nowhere left for the salt to dissolve into, and therefore you get it just sinking to the bottom. So if we go back to our example of adding salt or sugar to water, once you've added enough of it and it becomes saturated, any sugar or salt that you add to it will just sink to the bottom because it can't dissolve anymore because there's no spaces in between the water particles. So we need to be able to describe and explain filtration. So this slide shows a typical setup, a nice labeled diagram showing what's happening when we filter. So we have our conical flask, we have a filter funnel that we put in the conical flask, and the conical flask is better than the beaker here because it will hold the filter funnel better. And in the filter funnel, you put some filter paper, and you can see labeled we've got the residue and the filtrate. So the residue is the solid that doesn't go through the filter paper and collects on the filter paper, and the filtrate is the solution that goes through the filter paper and collects in the conical flask. So we use filtration to separate an insoluble solid from a liquid or solution. So if a substance was soluble, this method wouldn't work because it would go through the holes in the filter paper. So we need to be able to explain how it works. So it works because the filter paper has got very tiny holes in it, and the solvent particles and the solute that's dissolved are small enough to go through those tiny holes, because remember, when we looked at our diagram, the solutes in very tiny particles are spread out in between the solvent particles. So because they're very small particles, they're small enough to go through the tiny holes, and they can go and collect in the conical flask. However, any solid that's insoluble is going to be in larger particles, and those particles are too big to go through the holes in the filter paper, so they just collect in the filter paper. We also need to know about the method crystallization. So crystallization is separating a soluble solid from a solution. So because it's soluble, we can't filter it because it would go through the filter paper. So what we do here instead, so we've got something dissolved in a solution. So what we do is we evaporate the solvent until we get a saturated solution. And we know it's saturated because we'll start seeing small amounts of solid coming out. And once we've done that, we turn off whatever we're using to evaporate the solvent. So we'd normally use a Bunsen burner, and we allow the solution to cool. And once it's cooled, you will get crystals coming out. So once the crystals are formed, you can then use filtration to separate the crystals from the remainder of the solution. You would allow the solid to dry. You can do this either by patting it dry with filter paper or by placing it in a warm oven. And then you will have pure crystals of your solid.